like following along at home. Cool. So I got just stuff to tell you, and then once I've told you stuff, I will just field questions, and then it will be work period to just let you get stuff done here instead of at home. So, but I'll sort of get into the details of that. So to start with, I'm not going to change much, if anything, about how we're doing this class. I've had lots of good feedback about the videos. You like the videos. It seems to be effective. I think the one advantage of this is that it will be easier for you to ask questions because you're in here instead of sitting on a Zoom meeting, and it's hard to ask questions on a Zoom meeting anyway. Better than nothing, but this will at least let you just say, oh, well, hey, here's the question I have, and then I can, I don't know, more effectively or as effectively explain it. And then just the personal contact, which I think is, as I have mentioned, is cool. So we'll just keep doing videos. It's called a flipped classroom, in case you guys hadn't heard the phrase before. A flipped classroom. A normal classroom is you come in, I teach you something, you go home and you practice. The problem with a normal classroom is that, well, how do you practice? Morning.
This isn't a normal classroom?
This is the other half of my calculus. You know all these guys. You had them all last year.
Oh, I didn't recognize you for the first time. You got anything else for KCBA?
No. I just needed the whiteboard cleaner, so.
Thank you.
And so the problem with a normal classroom is that then you're at home trying to practice a concept that you may not have completely understood during class, and you don't have any help. So a flipped classroom, where you watch the lecture and watch the examples on the video. Well, now you're here doing the practice, and you can say, hey, Mr. Farmer, I don't see how that applies to this problem, or I'm fuzzy on what step 3 was in that process you did. And it's actually way better. Now, what's the downside of a flipped classroom? You have to have a motivated, enthusiastic class of students who all actually watch the videos. I gave a quiz to my first period Algebra 2 students last week, and it was here's your homework, go home and do this quiz. And out of 24 students, 11 of them actually even bothered to do the quiz. Well, that was a quiz. Can you imagine how many of them bother to watch the instructional video? Or watch it even, and then the ones that do watch it just sort of turn it on and sit there for 7 minutes and go, and it's, oh, I didn't get it. So we can do this in calculus because you guys are motivated, you're smart, you're enthusiastic, and it works nicely and it's better. So that's my plan. Couple things about the classroom. You guys are more than welcome to bring food. Normally, those of you who've been in my class before, should just turn to I highly discourage food and drink in my classroom because I don't want it to get gross. On the other hand, we're not sitting in groups. Things aren't getting knocked over. So if you need to bring food or drink, I'm fine with it. It doesn't bother me in the slightest now for what we're doing now. And I know that it's such a different schedule. You guys probably seen this because this is your first day. This is the schedule. This is Monday, Tuesday, and then again Wednesday, Thursday. So you guys have this day, second period followed by homeroom. So here followed by your homeroom. Fourth period, T3 in fourth period classroom, and then sixth period. Tomorrow you'll have this period followed by T3 in this classroom. Fourth period, sixth period, followed by T3 in sixth period. So every class gets a half-hour T3. Most teachers, because we've lost so much time, only seeing you 2 days a week, what I've been doing is I've been trying to every T3 period have some kind of worksheet so that I'm not just teaching, but they're doing like an extra practice worksheet. For you guys, I'm not planning on, I may, if there's some ideas in here that are complicated enough that I may have some sort of little practice thing to just, sort of like think about chain rule. when we did inner outer functions and we had to identify the inner outer functions, I may on occasion try to grab that time and do a little bit of something. There's not that many ideas that I think that are complicated enough that we need to do that. I've probably got 3 or 4 over the course of the year where I think, yeah, you know what, this is really something that we need to reinforce. So other than that, what you're going to be doing in here is a whole lot of come prepared with questions and work on the assignments. If you were completely done with all the assignments, I got no problem with you working on other stuff for other classes. Honestly, I would prefer that you then just sort of hold off on finishing your assignments so that you can work on them here, because I liked what I discovered Monday and Tuesday was just walking around and looking at people's work. I was finding issues and say, oh, wait. And so I think it was helpful for the folks in my A group to have me look at their work and say, hang on a second, we got a problem here. I don't want to check your homework. I don't want to review it all. It's tedious and time consuming, but it just is useful if you get a little bit more feedback. So if you can do your other projects at home or during those classes, and then try to save as much of your math as possible for when you come in here. And I don't see any reason. I mean, heck, we got, what's that, 1 hour and 10 minutes twice plus another half an hour. That's 2.5, 3 hours. I don't know how long it normally takes you guys to do a section's worth of homework, but I would think 3 hours would eat it. Completely lost my words. You'd get a lot of it done. So, and then scheduling wise, my plan. So this tomorrow, Thursday, I'm going to drop the 4.3 quiz, and it's still going to be informative. I'm liking the way formative works. I think I'm just going to keep using it. So the quiz won't be during class. It'll open up after class, and then you can, just do it over the weekend. On Friday, I'm going to drop the chapter 4 review. Well, actually, those might already be up, but because there's no videos for chapter 4. Video? Should I do a video? I might do a video for chapter 4 review just to go over honestly, chapter 4, and I'll talk about this in a minute. Chapter 4 is pretty straightforward, so I don't know if there's need. That might be why I didn't make a video. On Tuesday, and this is the 9th, I'm going to put the 4.4 quiz up. Again, it's just more derivatives, and we'll talk about it. And then on Thursday of next week, I'm going to drop the chapter 4 test, so you'll have that to do over the weekend. And then on Friday, I'll put up the 5.1 videos. It's a quick run between these quizzes, but that's mainly just because that 4.3 has been out there for so long when we didn't technically have calculus that I didn't want to then sit around for a whole nother week waiting for the 4.4. And again, chapter 4 is just so much, more derivatives. It's not really any new concepts. It's just new functions. So hopefully you're finding that chapter 4 is pretty straightforward and not super complicated. Snow days, you guys know that if there is snow and the school is closed, we just switch to Zoom. And so it's a little bit late. I don't know why. Why we have to have an hour late arrival because there's snow when we're doing it electronically. But hey, there's the schedule they gave me. Probably because they figured since there's no T3 or homeroom, they would let you sleep in and still finish at the same time. So that's probably why. That's mostly, you guys all know how to use Canvas? Have you used Canvas on your Chromebook? Are you using DocHub in your Chromebook, or are you guys doing all your work in your books? If you're using your Chromebook and doing assignments online, DocHub sucks. So who's used DocHub?
Like just like science syllabus.
Okay. And have you used any of you used Canvas? So you're just doing all your work on paper? Okay. Okay. DocHub is a program that you can write on PDFs in the Chromebooks. It's horrendous. The problem is that the document is saved on a server, the document hub. So when you write on it, it has to tell the server that you're writing, and then the server comes back and shows you what you've written. So there's these like huge lags when you're writing stuff. You write your name, and then you have to like count to 3, and then your name shows up. And so it's awful. It's really hard to do things neatly and accurately. Canvas is a Chromebook or a Google Chrome program that is much, much nicer. So if you ever do want to do work on a tablet, Canvas is a much better option. So, but if you're not using it, I won't spend any more time talking about it. You don't need to know any of that stuff because that doesn't apply to you guys. Do me a favor. Have your phones put away before you come into my classroom. I just do that as a flat out everybody. I try to remember to turn my phone, like the ringer, completely off. The only reason I even have it out is because I play music through the speakers. But I don't like phones being out. They're a distraction. So, and there's all sorts of science behind the having your attention split with phones actually really hurts your ability to focus and learn stuff and remember stuff. So I just ask that everybody put them in your backpack, not even in your pocket, because then it's vibrating in your pocket. Boom, distraction. Okay. Any questions so far on what we're going to do or how this is going to go? Okay. Are any of you planning on taking the AP test? Because I feel like at one point you said you thought you were going to. No? Okay. Okay. I just wanted to make sure because we switched the whole list over to nobody taking the AP test online for some reason. It defaults to yes. The College Board wants you to take the test because then they get your $100. And they are a for-profit business. They make money selling AP tests. As I explained to you guys, there's no way we're going to get through enough. So it would have been a lot if you'd wanted to take the AP test. There would have been a ton of learning stuff on your own. And of course, the problem with the stuff you need to learn on your own comes after the stuff we're doing in class. So it would have really been a bit of a nightmare. Did any of you guys do Everett Community College? I know a couple people did, but I don't know if it was anybody here. No? Okay. Okay. Because I told Everett that they wanted to know what we were going to be teaching this year because Everett's a 2 semester. And I said, I can guarantee we'll get through the first semester. So I'm telling the people who took first semester Everett, don't take second semester. Don't sign up for it because I'm not going to teach you that stuff. We're not going to get through it. Okay, cool. So none of the questions I had apply to you guys. Guys, let me just, since I'm here, let me emphasize a couple really, really important concepts. And then I'll just take wide open, what questions do you have? What would you like me to go over now that we're standing here? And the first one I really want to emphasize, and these are basically things, these are things that people either just forget or are a little fuzzy about, well, why would we do that? And the first one is using the definition of derivative in order to find a derivative. So right now, you guys know that if y is equal to x squared, that I can find the derivative of y with respect to x using the power rule. So anytime you see x squared, all you have to do is write down the derivative is 2x. And that's fine. But the way we got this rule is we started by doing the definition of derivative and coming up with that the derivative of that was this, and then we gradually started to see patterns, and when we saw patterns, then we were able to say, oh, hey, there's a pattern there. Could we prove that the pattern works? And that was the, remember when we proved that the derivative of y equals x to the n was nx to the n minus 1. Well, the only reason we tried to prove that is because we kept seeing these patterns. We would use the definition of derivative for x cubed, and we got 3x squared. And then for x to the fourth, we got 4x to the third. And after a while, you're like, hey, wait, every time I take a derivative of a polynomial, I get that pattern. Now, can I prove that it works for every possible version of that? And that was the proof that I did on one of the videos. Actually, I think we've done it 3 times, because we started with whole numbers, and then we said, well, let's see if it works for integers, and then we said, let's see if it works for rational fractions, and then most recently, we proved that it works for irrational numbers, so x to the pi, for example. But that came from this definition. That's the definition of derivative. And if you think about it, if we look at a graph, there's x. There's x plus h further up the graph. This is f of x. And this is f of x plus h. And the slope of this line is the change in y over the change in x. Change in y, f of x plus h minus f of x. Change in x, h, because that's how far I moved. Now, when I take the limit as h goes to 0, what I'm saying is, well, then let's just take that point and move it that way. How far? Further. Do I stop there? No, you keep going. Well, shall I stop there? No, keep going. Shall I stop there? Keep going. No, just keep going, keep going, keep going. And that's the idea of a limit. Remember when we talked about limits in chapter 2, right at the beginning of the year, and we said a limit is not a place. It's where you think you'll be when you get there. Remember the limits? We had the bugs. You guys remember my bugs? And the limit as the bug approaches x equals whatever is 2. Will he ever be at 2? No, because his function doesn't exist at 2. But he thinks he will be at 2 if he keeps going long enough. So h can't be 0. You can't calculate the slope if you only have 1 point. But what you can do is you can calculate the slope if you have 2 points that are infinitely close together. 1 and 1.00000000000. Keep going as long as you want, and then stick a little 1 at the end of that. Really, really close together. But then what we do is we say, well, we're not going to actually calculate it at 1 and 1.00, all these zeros and a 1. We're just going to say, where will we be if we keep going there? So when I look at this function, f prime of x equals, using this function, the limit, as h approaches 0, of x plus h squared minus x squared divided by h. And now we just do algebra. X squared plus 2hx plus h squared minus x squared divided by h. Limit as h goes to 0. Subtract. Factor out an h, and I've got h times 2x plus h divided by h. Limit as h goes to 0. That's 1. no matter how small h gets, infinitely small divided by the same infinitely small is 1. And I'm left with 2x plus h. Well, what happens is h goes to 0, that goes away, and I'm left with 2x. So finding derivatives just becomes a matter of being able to do algebra. Just because the algebra can be complicated. But part of what learning how to do this kind of math is what are the tricks? You can brute force your way through almost many of these, but there are tricks that make it easy. One of the tricks is the Pascal's triangle. One, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So what use is that? Well, what if I wanted to find the derivative of x cubed? What do I have on the top? I've got x plus h cubed minus x cubed over h. Well, what's x plus h cubed? Well, it's complicated. I got to times x plus h times x plus h, and then I got to multiply that by another x plus h, and it takes a while. Oh. Or I recognize that it's x cubed plus 3x squared h plus 3xh squared plus h cubed. 1, 3, 3, 1. Oh, hey, look. Now that's easy. Because now I can just take that and plug it in for this and simplify. Ready? What's the derivative of x to the 5th? X plus h squared times x plus h squared. So I've got x squared plus 2xh plus h squared times x squared plus 2xhx plus h squared. And then when I figure that out, I've got to multiply it by x plus h. And I get this really long thing, and I combine like terms, and I probably make a mistake. Somewhere in the midst of all of that, I make something a squared instead of not a squared, or I combine two things wrong, or I say, oh look, 5th power, 1, 2, 3, 4, 5. X to the 5th plus 5x to the 4th h plus 10x cubed h squared plus 10x squared h cubed plus 5x h to the 4th plus h to the 5th. That is x plus h to the 5th. And now I can subtract x to the 5th from that side and divide by h. Start simplifying. Oh, look, x to the 5th minus x to the 5th. These all have h's in them, so I'll factor out blah, 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 blah. And what am I left with at the end? 5x to the 4th. Because all of these will go to 0 when I take the limit as h goes to 0. That's a trick. Other tricks. Properties of exponents. X to the n to the m equals x to the n times m, and vice versa. We used one, well, we're going to use one in 4.4 if you've started working on that. X to the n times x to the m is equal to x to the n plus m. That's just a trick. So you're going to see in 4.4, you're going to see e to the x plus h minus e to the x divided by h. Well, what the heck do I do with that? Oh, look. This is e to the x times e to the h minus e to the x. And I can factor out an e to the x. And if I'm taking the limit as h goes to 0, notice that this isn't dependent on h. So I can just move that out front because it's completely independent of h. And now I have e to the x times the limit as h goes to 0 of e to the h minus 1 over h. Well, we do have a bit of a problem here, is that that would be 1 minus 1 over 0, so that's 0 over 0. But when I look at a graph in the calculator, this is equal to 1. I can see it on a graph. That's not a mathematical proof, by the way. Looking at a calculator is not a proof. But given that we don't really want to prove it, we just want to know what the derivative of e to the x is. Again, the point here isn't the derivative of e to the x. The point is that we had a trick. And the trick allowed us to take something that is really complicated and turn it into something uncomplicated. Okay? Looking in your calculator, that's another trick. It's not always a good trick. You got to be a little bit careful. If the question is prove, you don't want to look in your calculator. But if the question is what is, maybe looking in your calculator is a good strategy, especially if it's a complicated function. So what do I want you to take away from everything I've just said here? Thing one, is you should know this definition of derivative, because there will be questions asked that say, use the definition of derivative to find. In fact, you've seen those on tests in the past already. And we ran into the problem of some people just went straight to the derivative because they knew the rule. But the question said, use definition of derivative to find. The AP test has a lot of these, because they're testing not can you memorize a rule, they're testing do you understand the definition of a derivative. I know we're not taking the AP test, but the concept is the same. When you guys go off to college next year and you're in whatever it is you're going to take, engineering or whatever, you sit in a calculus class, you need to know that. All right. What other tricks can I think of that just to illustrate the point? Probably none right now. Let's talk about very quickly rules for derivatives. And I'll show you some common traps people fall into. So these are rules for derivatives. Let's see. First off, let's start with the sum rule. The derivative of u plus v, and we'll assume that u and v are differentiable functions of x. Everybody understand that notation? U and v are functions of x and they're differentiable. Okay. You can just split them up. Makes life easy because you just do that one and then you do that one and then you add them together. Constant multiplier rule. Guys, this is a trick that makes your life much easier. The derivative of a constant times a function, C is a constant, is the constant times the derivative of the function, which means you can simplify by moving the constants out front. Just otherwise, if you're having to carry the constant through every step of finding the derivative, it just makes every step more complicated. And just keep that in mind, that if I ask you to find the derivative of pi over 2 sine of x, and let's say that we're not using the rule, we're using the definition. Well, do I want to have pi over 2 sine of x plus h minus pi over 2 sine of x all divided by h? Well, that's just complicated. as opposed to easier. Now you do this and there's pi over 2 out front. So just keep that in mind. People they confuse themselves on a regular basis because they forget, hey, just take that constant and put it out front. Derivative of a constant function. This is a fun one. The derivative of a constant is 0. Think about the equation y equals 3. What's the slope? 0. That's a horizontal line. So when you see this, find the derivative of pi cubed. What do you think the common answer is? Oh, look, it's a power. I'll use the power rule. Yeah, it's a power, but pi cubed is a number. Pi cubed is like 30. So what I'm really asking is find the derivative of y equals 30. Oh, that's 0. So as you're going through and you're thinking about these things, be very, very careful about, is something a function of a variable? You can't take the derivative of something that's not a function of a variable. And that throws people on a pretty regular basis. Okay, product rule. The derivative of two functions that are multiplied is u times the derivative of the first times derivative of the second plus the second times the derivative of the first. This one people tend to overlook when one of them's complicated and one of them's simple. For example, if I asked you to find the derivative of x times the inverse sine of x squared plus x, that's a function. This is a function. I would say that this is the most likely case, like I say, for people to forget that it's a product, because that's so simple that they immediately focus on, whoa, arc sine and chain rule, and oh my gosh, what do I do now? I've got to do, and they forget that they still have to deal with that. And so then u prime is 1, and then v prime is complicated squiggly push. All right. Quotient rule. And then I will show you a trick regarding the quotient rule. The derivative with respect to x of u over v du minus u dv divided by v squared. Okay, there's the quotient rule. Here's the trick. What if I give you y equals 3 divided by x squared? Very commonly, people say, oh, I'll use the quotient rule. And it works. U is equal to 3. V is equal to x squared. The derivative of u is 0. The derivative of v is 2x. So the derivative of y is, well, v du. Oh, look. That was sort of pointless. Minus u dv divided by v squared. Well, now I have to simplify. And so this becomes negative 6x over x to the 4th. And this becomes negative 6 over x cubed. Okay, fine. I got that. 1, 2, 3, 4 steps. Well, wouldn't it be just easier to write y equals 3 times x to the negative 2? And the power rule says, and the constant multiplier rule says, the 3 stays there, the negative 2 comes out front, and that power gets reduced by 1. Negative 6x to the negative 3, which is negative 6 over x cubed. The trick is, if you don't have a function divided by a function, don't waste your time using the quotient rule. This is not a function divided by a function. This is a constant divided by a function. So anytime you have a function on the bottom, you can always write it as a negative power instead of using the quotient rule. And then it becomes a power rule instead of a quotient rule. And the power rule is a heck of a lot simpler than the quotient rule. So when you're deciding whether or not to use quotient rule, ask yourself, do I have function divided by function? And if you don't, then quotient rule is probably not the best strategy. Oh, I saw this one last year. This was awesome. And the student got it right. I mean, they got the right answer. Y equals x squared over 3. Quotient rule. U equals x squared, v equals 3. And after he was done, and I was looking at his work, and I said, is there some reason you didn't just write that as that? And then the derivative would be constant multiplier rule times power rule. And he looked at it and he said, oh, that never even occurred to me. He went through this big complicated thing where v prime is 0 and u prime is 2x, and put everything into there and then simplified, and it took him a significant amount of time. Hey, look, divided by 3 is the same as multiplied by 1/3. Guys, that's another algebra trick. Being able to go back and forth between division and multiplication, recognizing they're the exact same thing, can make things a lot simpler. All right. What other rules are there? Whoop. I drop things a lot wearing this mask because my downward peripheral vision is gone, and so things are out of sight that normally I would see. It's like, ugh. What are the other rules? Are there any more? Of course, that's plus or minus. I feel like that's it. I have a present for each of you. I know it's not that exciting. For a second, I know you were all like, yes! I just made these, all these different derivatives, all these different rules. Here's a little cheat sheet for you to write them on if you want. Don't have to, but anytime that you find the derivative of a function, not a bad idea to have them on there. Will I require you to memorize derivatives? Sort of. I will ask you to find the derivative of a product. You could derive the product rule right there on the spot, but maybe it's easier to memorize the product rule, and then you know it. Oh, chain rule. There's another one we should talk about. Guys, let me go back to my previous point. Look for patterns. Anytime you're thinking about derivatives, there are always patterns between related functions. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent, it's just got out of my head. I want to say 1 over secant squared. The derivative of cotangent is the negative 1 over cosecant squared. Pattern. It's always the negative and the opposite function. So it just makes it easier to memorize. If you're thinking, oh my gosh, there's 6 trig functions, sine, cosine, tangent, cosecant, secant, cotangent. Well, really you only have to measure 3 plus a pattern. It's easier to memorize 3 plus a pattern than it is to memorize 6. Same thing with the inverse, the arc ones that you're doing in chapter 4.3. if you're going to remember them, and by the way, I'm not going to require you to remember the derivatives of the arc functions, but I would recommend that in the long run, you start to store them away in your memory. But again, there are patterns. There's 6 of them, but really you only need 3 plus a pattern. And then you've got all 6 of them. All right. Chain rule. The trick with chain rule, and I love color coding chain rules, is figure out which is the innermost function, and then figure out in order the middle functions, and then find the outermost function. How do you do that? Well, the easiest way to do that is to say, if I were to plug in a number, what order would I do things in? If I wanted to find f of g of h of 2, what would I have to do in order to calculate that? Well, I would find h of 2, and then I would take the answer to that, and I would find g of that number, and then I would take the answer to that, and I would find f of that number. Oh, inner, middle, outer. So then when I'm taking this derivative, it's f prime, you start at the outside, of all the stuff that stays in here. This doesn't change. Times g prime, of all the stuff that's still inside, times h prime. So starting at the outside, take derivative, take derivative, take derivative. Now, where do people make mistakes on this one? Can I erase these, you guys? Cool. I guess I can erase this too. Is forgetting that this has to stay inside, and forgetting that this has to stay inside. So let's look at a quick example. Y equals sine of x squared. If I said, what's y of 2? You would say, I square it, and then I take the sine. Agreed? So squared is the inner, sine is the outer. So what's the derivative? Y prime is equal to, well, derivative of the outer is cosine, times the derivative of the inner is 2x. Here's the mistake. Derivative of sine of x is cosine of x. But this isn't the derivative of sine of x, it's the derivative of sine of x squared. This is why sometimes we use substitution. I rewrite this as y equals sine of u. And the derivative of y is cosine of u times the derivative of u. That's the reason for this notation. One of the questions I had on Monday was, why does every derivative have 2 versions, one with an x and one with a u? And the reason is because the u is chain rule. Now, you do x. Can you do chain rule if you just had sine of x? You can, but it's pointless. I'll explain why. What if I had just said y is equal to sine of x? What's the derivative of y? Well, let's write that out. It's the derivative of sine times the derivative of x. Oh, but the derivative of x is just 1. So if there's just an x in there, theoretically chain rule does apply, but it's just like we don't write 1 in front of every function that we write, because we understand that y equals sine of x means 1 sine of x. We don't write it every single time. So we don't have to use the chain rule if it's just an x, but we do if it's some function of x. Okay? So just be careful as you're working through chain rule problems that you always plug the original function back in as you're doing that. Okay, I have now talked for 45 minutes. Do you guys have questions you want me to answer? that are sort of been floating around in your mind waiting for this opportunity. Could be about the class, could be about the math. No? We good? Okay. So we've got 25 minutes left. Work time for you. Work on calculus if you've got calculus to do. If you have finished an assignment and you need to start watching the next videos, either headphones or I guess the subtitle seems to work. I've been told by students that they watch the videos all the time with just the subtitles and they're just reading what I'm saying instead of listening to me, which I think would be weird, but I watch old martial arts movies in Korean and Japanese, and it's really annoying to have to read the subtitles the whole time. But there it is, it can be done. So you got 25 minutes to get stuff done, and then you're going to go to homeroom, and then I'll see you tomorrow. And last thing I'll say is, as you're working through stuff, make lists of questions so that when you come in, if you got questions, you don't leave at the end of the day, oh, I was going to ask them this and then I forgot. If you got a question, if it's something you just can't figure out, make yourself a note somewhere so that you can ask me. And you don't have to ask me. I mean, I don't have to answer your questions in front of everybody unless everybody's like, oh, yeah. No, I want to know that too. But have questions ready for me as they pop up so that you don't then leave and feel like, oh, I missed an opportunity. Cool. All right. It's all you. I'm going to stop the live stream so that I can play music. I got a copyright violation right when I started doing this. I forgot to turn off the